Hi, welcome to our first interactive, or not interactive, our first online whiteboard physics lesson. I've been doing these with chemistry. The results have been pretty positive. So this is how I'm going to do your notes for chapter 8. Okay, so we started chapter 8 and you guys read, you watched that video on Newton and then you looked at the different scientists. We started off with Tycho Brahe. We went on to Kepler, Copernicus, Edmund Halley. I think they circle back to Newton. And every one of those scientists had a different view of what the universe looked like. Starting with Tycho Brahe had a really interesting life. If you didn't get a chance, I'll include the link to it. The YouTube video for Tycho Brahe he led a pretty crazy life. He was kidnapped by, I think, an uncle. He lost his nose in a sword fight and had a gold prosthetic nose. He died suddenly. They thought it was from drinking, but he might have had a kidney infection, not gone to the bathroom, something like that. I didn't watch the video this year, but we've watched it in previous years. So the video on Tycho Brahe is pretty interesting. He's from Denmark. He was essentially given his own island by the king of Denmark. And Tycho Brahe was one of the guys who kind of towed the company line. So if the church believed it, Tycho was going to support it. A couple of interesting things about Tycho Brahe. He observed an eclipse. And his observation of this eclipse gave him the idea that things in space, things in the heavens moved because the eclipse didn't happen all the time. It was once every, X amount of years. So he observed this eclipse, and him, in terms of towing the company line, did not believe that the sun was the center of the universe. He believed in an Earth-centered universe. Tycho Brahe also believed in a perfect circular orbit. And I think we've talked about informally in here that the planets do not orbit the sun in a perfect circle. The planets orbit the sun in, for the most part, an elliptical shape. It can be wobbly at some points. But everything that Tycho believed eventually was proven false. And who was it proven false by? It was proven false by his assistant. His assistant was also Danish, Johannes Kepler. Right, so I believe that there were at least two videos for Kepler that you were supposed to watch. One was a little bit about him, and then the other was about his three laws. So for Kepler, he believed basically everything opposite of Tycho. And so Tycho believed Earth-centered. Johannes Kepler believed that we were a sun-centered universe. And we've talked about that word. The prefix helio means sun. So the most abundant gas on the sun is helium. That's how helium gets its prefix. So we are a heliocentric universe. Okay. So Kepler is going to incorporate a little bit more math than Tycho Brahe does. And he comes up with Kepler's laws of planetary motion. And all this is taking place, in like the early mid 1600s. So it's kind of like the dawn of the scientific revolution. Newton hasn't invented calculus yet. Stephen Hawking definitely not around. So for Kepler to make these claims and for majority of them to be correct is pretty stunning. All right, so his first three laws. The first law, according to your textbook, I have it right beside me. I'm reading out of it. The first law says the paths of the planets are ellipses with the sun at one focus. All right. So planets are ellipses. I'm sorry, planet paths are ellipses. And if you know anything about an ellipse, if you remember studying those shapes, it kind of looks like, I'm horrible at drawing these, kind of looks like an egg. It's about as good as we're going to get. It's kind of not a non-perfect oval. I think the first one was better. Okay. So an ellipse has two centers. And at one center of this ellipse is the sun. So an ellipse has two centers. And one center is the sun. All right, so I don't know what the other one is. So yeah, that is Kepler's first law, is he determined that the path of the planets are elliptical. So that goes against Tycho Brahe. All right, the second law, according to your textbook, states an imaginary line from the sun to a planet sweeps out equal areas in equal time intervals. Thus, planets move faster when they are closer to the sun and slower when they are further away. So, planets move faster when they're closer to the sun. Okay, so planets move faster when they're closer to the sun. I kind of think about it as like maybe like an amusement park ride, like the Tilt-A-Whirl or something like that, where all of a sudden you feel like you're being slingshotted around. That's kind of what I envision happening when planets, and obviously it's not a slingshot. We don't move that fast, but we're moving. We get a little bit faster, and then we get slower. Then we move really slow. And then as we approach, we get a little bit faster and we get slower. So planets move faster when they're closer to the sun. And then conversely, they move slower when they're further away. Sorry, my handwriting is horrible. Slower when further away. All right, that's his second law. The third law is just kind of like how Newton had two regular laws of motion and then one law was an equation. Same thing with Kepler. Kepler has two regular wordy laws, and then his third law is an equation. We're going to work with that equation tomorrow. According to your textbook, it says the square of the ratio of the periods of any two planets revolving around the sun is equal to the cube of the ratio of their distances from the sun. Okay, so the ratio of the period squared equals the ratio of the radius cubed. So remember, T stands for period. So T sub A and T sub B, so one planet and a second planet. Their ratio squared is equal to the distance or the radius of both of them cubed. Okay. Um, T equals period. So usually the time it takes to revolve. And R equals radius or distance. And we're gonna start tomorrow's lesson with working with the equations. So today I just wanted you guys to get used to um, listening to these videos and to keep your notes somewhere because you will need to use these. So what I did with chemistry, and I'm going to do this for you guys, your attendance tracker. Attendance tracker. Sometimes I'll say, see the end of the videos for your attendance. So your attendance tracker today, what you're going to do is you're going to take a picture of your notes and you're going to post it under Tuesday in the attendance tracker. Okay. And that is your classwork and homework for today, is to copy down these notes and to post it on the attendance tracker. And I will check back in on Wednesday with calculations. So Wednesday, you will need a calculator. Thank you.